Okay, so last week we discussed about, I think you all can hear me. Please, here is a chat. If you can hear me, please send me a message. Anyone? Okay, thank you, Dilina. So here, if you go to the LMS, in the LMS, you can see in week 3, I have uploaded these 2 lectures, and also you have an activity to do and the answer sheet. So after this online session, I'll be available at LMS or my CGs online. Here you can see in CGs online in week 3, you have a chat. In this chat, I will be available in this chat. So if you have any question, you can ask through this chat. And also, so then we'll start the lesson. So last week, I think you can follow me. I think the sound is clear for you. So last week we discussed about flowchart symbols and all. So here today we'll discuss about some programming basics. So at first we'll see how to use and name variables. So I think, so I assume that all of you, maybe some of you have this knowledge, but I assume that all of you are new to this thing. So I'm going to describe it from the beginning. So we'll at first we'll see what is a variable. Actually, a variable is a symbol or a letter that can represent a value. That means if we consider about a variable, this variable has a value and a memory location. For examples, we are assigning some values to variables. So this variable has a name, and this value is saved in somewhere in the storage. So what we can say here is this storage has a name. That name is the name of the variable, and also this variable has a value. This value, the content of this value can vary. For example, it can be a string, that means it can be a text, a value, that means a number or anything. And if we assign something to a variable, then the variable is always in the left hand side of the equation mark, and the value is on the right hand side. And if we assign and the value, that means the value of the, not the name, the value of the variable, we can use these values to do operations. For examples, here in this example, you can see value of x is equal to 1. That means x is the variable and the variable's value is equal to 1. So we can use this variable value to do many operations. For examples, I can add a 1, or I can increase the value of variable x by 1. That means I can add 1 point to the value of x, or else I can multiply this value by any other value like this. So, and also we call this variable as an identifier. So we can say this is a variable, or we can say this is an identifier. So in each program language, they have different naming rules. For examples, for some programs, they have legal characters. That means some characters in some programs, some characters can't be used as a variable name. Some characters can't be used in variable names. And also, definitely, every program has a maximal length for a variable name. And there are rules for using upper or lower cases. Here, the exact rule for every variable in every programs is that the variable name must be a single word. So it is easy to assign a single word if you have very simple variables. But if you need to use more complex variables, then maybe sometimes you need to use more than 2 words. So for these things, here you have an example. So here at first, if the name is simple, then we can only use the name rate. So here you have only one word. So, but if you need to connect more than 2 words, this is what you can do. You can start the first letter of the next word using a capital letter. Here you can see interest rate. So here you can clearly see there are 2 words, but there are no spaces. So in a variable name, we can't use spaces. So instead of using a space here, they have used the interest rate name. And here you can see the letter of the second word is they have capitalized the second they have capitalized the letter of the first letter of the second word. And also instead of that, we can use the third one as interest rate. That means instead of having a space, we can space this space with a colon or with a hyphen. So here you can see interest rate. Here instead of the space, they have replaced the space with a hyphen. So what the thing you have remember is we can't use spaces in a variable name. So if we use a space in a variable name, that means there are 2 words. So instead of using variable, instead of using a space in variable names, you can use these 2 techniques. That means you can always capitalize the first letter of a new word, or else you can replace the spaces with a hyphen. And also you should choose meaningful names for variables. Reason for that is when you do the coding now, then you can understand why you use this variable and the reason for using this variable. But if after some time, if you again look at this, look at your code, then you can't understand. Maybe you can't remember why you use this variable, and you don't understand why. What is the meaning of these variables? And also, if not you, if anyone is looking at your code, then again they don't have a clear understanding of these variables. So for this, you should use meaningful names for variables. So if you use the meaningful names of variables, this will improve the readability and maintainability of your code. So here are some examples. So in the first example, you can see employee last name. It is a good variable name. Here you can see, we can see 3 words. And after the first word, every word is combined, connected with a capital letter. And then here, the second one, employee last. So in programming, when we use this last, in programming, so I think if you do this programming further, the most programmers familiar with this last word. That means the last means the last name. So most people can interpret this as this word last as last name. So second one is also a good variable name. And emplast, here you can see I have encrypted both employee and the last name. So this is also readable. Most of people know if emp mean employee and last mean last name. And here we have another name, AMPLSTANAM. This is legal, but not very good because lots of people can understand what is the name, what is the meaning of name, because this is cryptic. And then we have this, in the next variable name, we have long variable name with lots of information, last name of the employee in question. This is awkward because we don't need this much information in a variable, and it is hard to use and manage this variable in your code. Okay. And the third one, we have the last name, and here you can clearly see there is a space between these two words, and that means this is not a single name, this single word, and here you can see two words. So this is not a legal name. And here you can see employee last name. This is legal, but here you can't identify the words. There are three words, but here you can't identify these words clearly and separately. So it is hard to read if you have only one word, if you have this long one word. Okay. So I think you have some idea about how to name a variable. So we'll see how to assign values to variables. So this is how we can assign values to variables. That means we have a variable, then if to use this variable to do operations, then we have to assign some value to this variable. So here in the assignment statement, always the variable is on the left hand side, and the value that we are assigning should be in the right hand side of the assignment operator. And in the right hand side, there can be a value, or there can be an expression that will be evaluated at the program running time and store the value to the variable. So in most of programs, most of languages, the assignment operator is equal to this equal sign. So next we'll understand data types. In general, in every language, we can see these basic data types. First one is text data type, and the other one is numeric data type. So in text data type, we store the numbers. For example, if you need to store 10, 100 or any number, then you should use this numeric data type. And in text data type, we store the strings, text or characters. For example, if you need to store your name, then you should use this text data type. And also in programs, we can see variables. So constant variables. So if you see this numeric data and text data, we can change these the values of these variables at any place or at any step of our program. But when we consider about these constants, we can't change the values of these constants while the program is running. That means at the beginning of the program, we are assigning some value to these constants, and we can't change this value of constant. That means in the entire program, the value of constant will remain unchanged. This have identified, and also so these constant can be used in calculations and can do everything that a variable can do. The only thing the constant can't do is assigning new values or change the constant's values. So in some programming languages, we can divide. They have many types in data types in numeric data types. Yes, Sunet, a constant is a fixed variable. So at the beginning of the program, we are assigning some values to a constant. So after that, during the program, when the program is running, we can't change the value of a constant. I think you understand the concept. And so here, when we consider about numeric data types, many programs have in programming languages, we can have many number of numeric data types. So here, for examples, most of programs have this integer data type. So in integers, you can only save whole numbers. For example, you can save 0, 1, 2, 3, 4, 100, 1000. All these only you can save in these integers. Only you can save whole numbers. And in floating point, that means if you need to store a fraction number or decimal points, then you can't use these integer data types. Instead, you have to use this floating point data types. For example, if you need to store the value 0.02, then you should use this floating point data type. And when we consider about the character data types or text data types, when we assign some values, or if we we represent the value of a data, text data, then you should always include this value inside double quotations. Okay, that means string data, text data should always be inside double quotations. Okay, and data types these data types must be used appropriately. We can do some operations in these data types. We can assign values to these data types, but these must be in an appropriate manner. So we'll see. So here you can see, as at first we'll assume last name and first name are character variables. That means what's happening here? Okay, so at first here we can see the last name. We'll start from the beginning. So here you can see, at first we'll assume the last name and the first name are the character or text variables, and quiz score and homework score are the numeric variables. So at first we can see last name, we have assigned a value, a text value to the last name. So here you can see the name Parker is inside the quotations, that because it should be, because we are assigning this value to a text variable or character variable. So always this text or string should be inside a double quotation. So the first thing is correct. Okay, but see the second one here, you have assigned the last name Parker to the last name, but here you can't see in double quotation. So if the Parker is a value, then this is wrong. But if the Parker is a variable name of a string data type or character variable, then this could be right. For example, think last name is a character variable, and also think Parker is not a value, Parker is also a character variable. So if it is true, then the second in the first line, the second column, in the second column, we can say this one is correct. So, but at this time we don't have any character variable named Parker, so we can, okay, here you can, so okay, I'll explain it again. Here we have character variables name, last name and first name. Okay, I think you can understand that. So I need to assign some value to last name. So since this last name is a text variable, so to assign the values, I should use the value inside the double quotations. I think you can understand this, because last name is a character or string variable. So if we assign some string variables, or if we display these string variables, then the value of these string variables always should be within quotations. I think you understood that. Then that's why in the first row, the first column, in the first row, in the first column, the expression is right. But in the second column, you can see they are assigning Parker value to the last name, but this Parker value is not within the quotation marks. So therefore, we can say this is wrong because we are assigning some string value to a string variable, sorry, a text value to a text variable, but this text value is not within the quotations. So I think you have understand this one also, but think if the Parker, if the Parker is not a value, think Parker is a character variable like last name and first name. Again, I'll tell you. Consider Parker is not a value. For example, consider Parker as a character variable. So this, so if the Parker is a character variable, then this equation could be correct. So I'll explain it later here. We have more examples. I think if we, at the end of these examples, you will understand this concept. And then we'll go to the second row. Here, the first name equal to Laura. So you know it is correct because the first name is a text variable. And inside the quotations, they have assigning a value inside the quotation. Okay, okay, thank you, Sunil. Then here you can see the second one. It is wrong because the value must be in the here you can see the value, the variable name and the value have set. Always if you assign some value to variable, then the variable name should always be on the left hand side of the assignment operator and the value should always be on the right hand side of the operator. So I think you have understand what is wrong in this equation. Okay. And the next. So here you can see in the third row, I have assigned last name to the first name. So here you don't need to have the question, how can we do this? Because the first name is not within the quotations. The reason is the first name is also a character variable and the last name is also a character variable. So I am not assigning the value first name to the last name. I'm assigning the value of first name to the last name. So what is the value of the first name? So here, you know, we already assign a value to the first name. The value of the first name is Laura. So I'm assigning the value of the first name to the last name. It is the description. It is how the last, it is the explanation of the third row. And here you can see in the second column, last name is equal to Quizco. And this is completely wrong. Why is that? Last name is a character variable, but Quizco is a numeric variable. So we can't assign two different variables to each other. So if you need to assign some variable to a character variable, then you should definitely assign a character variable, not a numeric variable. I think you got it. And then see at the fourth row, here we have this Quizco and we have assigned 86, the value 86 to the Quizco. It is correct because Quizco is a numeric variable and 86 is a numeric value. So this one is correct. And the next we have homework score is equal to first name. Again, this is not correct because the reason is the data types does not match. Because homework score is a numeric variable and first name is a text variable. And in the fifth row, here you can see homework score is equal to quiz score. Again, this is correct because both variables are in the same data type. That is home score and quiz score is in the are in the numeric data types. And here homework score equals to 92. So what is the wrong in this? Homework score, okay, it is a numeric variable, and 92 also is a numeric value, but the matter here is, here the 92 is within the quotation mark. So if we display, or if we represent any number, anything inside the quotations, then the program consider it has a text. So although 92 is a variable, a numeric value, as it is inside the double quotation, then here this 92 is considered as a text data type. So we can't assign a text data type to a numeric data type. Yes, if we if we include anything inside, any number or anything inside the double quotations, then it become that, then that number become a text. So in the next, we have assigned quiz score equal to homework score plus 25. So I think at the beginning we discussed, we can in the right hand side of the operator, we can have a value, or else we can have an expression. So here you can see we have an expression. That means a quiz score equal to homework score plus 25. So this is also a correct thing, because we can do this calculation with these data variables, because those are number types. And then we have first name equals to 23. I think you can guess what is the wrong with this. This here, the data types does not match, because the first name is a text variable, and the second, the value that we are assigning is a numeric variable. And so to have a right statement, you can you can replace this 23, number 23, inside the double quotations. Then we can say this expression is correct. And in the last, you can see homework score is equal to 3 multiplied by 10. This is correct. We can, as I told you earlier, we can assign at the right hand side of the operator, we can have expressions, and this is an expression. And in the second column, it is again wrong, because they have swapped the places. The variable and the value have swapped the places. So value must be on, so always value on left must be a variable name and not a constant. Okay. So next we'll have a little understanding about the evaluation of programming techniques. So in the earlier ages of programming, people have to communicate with the computers directly. That means using machine code. I think you know what is a machine code. Machine code is the binary code. So at the earlier ages of programming or computers, there is no high-level language. So people have to learn machine code, which is not easy. That means it is not readable. It is not likely in human language. But now we have high-level language that developed to allow English-like instructions. So if now we read some programming codes, we can understand without having the knowledge of binary codes. Okay, and so I think you already know what's happened inside a computer. So we write programs in high-level languages, and inside the computer, interpreter or compiler convert these high-level languages into the machine language. In the last week, I think, last or any week. So then at the beginning of the programming, we have monolith or the procedural programs. That means the program runs from beginning to end. That means there is an up-down approach. And now we have newer program modules, for example, object-oriented program modules, and these can be combined to form programs. So we'll discuss about these program types. So now we have two major programming techniques, procedural programming and object-oriented programming. So in procedural programming, this focus on procedures, and instructions are given to, and here we are given every instruction to do one task, and they include logical steps. And also this paradigm uses linear, that means there is an top-down approach, and also here they treats data and procedures as two different entities. Examples for procedural languages we can tell C, Fortran, Pascal, and BASIC. And then we have the newer approaches, the object-oriented programming. In object-oriented programming, it focuses on objects rather than the logic, and we can think this object as a real-world things, and also this object has attributes and behaviors. And organize software designs, and we organize this software design around data objects rather than the functions and logic. So I think it is easy object-oriented programming in programming languages. For examples for object-oriented programming are C++, Java, Python, C#, and so on. So we'll have a summary of all these things we've learned up to now. So what are the major components of computer operations? They are input, processing, output, and storage. And in a program phase, we have 6 programming phases. First, you have to understand the problem and then plan the logic, then code the program and translate the program to machine language and test the program, deploy the program. And then we have this data hierarchy. So in a data hierarchy, the smallest thing is the character. Then we have a field. A field is consists of a field is consist of more than 1 characters, and a record is consist of few fields, and a file is consist of few records, and a database consists of few files. And we discuss about flowcharts. Flowcharts are the pictorial representation of the programming logic. And now we discuss about variables. Those are the named memory locations that contain values. And testing a value involves making a decision. And we discuss about assignment operate statements, store a variable into a variable, how to store a value to a variable. And in most languages, assignment operator is the equal sign. And there are 2 data types in every programming language. Those are text and numeric. And procedural programming focuses on actions performed on data, and in object-oriented programming, they focus on manipulating and representing objects. So this is the instruction to programming basics. So I think I'll start the next lecture also just now. Do you need any break? I think it is good if we start the next lecture. Okay, we'll start the next lecture now. Okay, take a 5-minute break. Okay, take a 5-minute break. Okay. Be here at 9:27. 7, okay? Be in the lecture at 9:27. Okay, we'll start the lecture. So, in object-oriented programming and procedural programming, there is no problem about security. The problem is we can reuse the codes in object-oriented programming, and if there is any bug in object-oriented programming code, then we can easily find that. And also, it is more like the environment around us. So it is easy to manipulate and do all those things. But in procedural programming, we have only a procedure that we have to do. We have to act according to logics. And if you need to do some changes in procedural programming, then it is very hard because there are lots of things we have to change. Sometimes it affects the entire program. But can you see the presentation? Here, flowcharts and pseudocode. And the problem in I'll again, okay, thank you. So I'll again explain in procedural languages, if you need to change the procedure, do any changes in the procedure, then you have, sometimes it affect the entire program because they all have connected. But in object-oriented programming, we consider these things as objects, everything as an object. So if we do anything, these objects are acting independently from each other. So if we do any change to these objects, there is no, it doesn't affect the entire program. So if you need to know more about this object-oriented programming and procedural programming, I'll upload an YouTube, so this is not in your the object-oriented programming. We are going to learn object-oriented programming, but to describe you about the object-oriented programming and procedural programming, actually not a unit of this course. So I'll do a YouTube lecture and upload this YouTube lecture, and I'll give you the link, and you can go and check and have more knowledge about this object-oriented programming and procedural programming. Okay, so let's start the lecture. So last week we discussed about flowcharts and pseudocodes. So here we'll learn more about these flowcharts. So when we discuss about the structures of a flowchart, we can divide a flowchart into 4 groups: sequence structure, decision structure, and repetition structure, and case structure. So for now, we'll have a little description of each structure, and next week we'll discuss more about these structures. So sequence structure is a series of actions that are performed in a sequence. That means, for example, you can see here, you can see a top-down approach. That means here you can see the program or this flowchart flows from beginning to end, and here you can't see any alternating paths or anything. Here you can see the flow from beginning to end. And we'll see what I'll describe this flowchart. Okay. Here, at first, you can see the symbol using the start or end symbol. We are starting this flowchart, and then we are getting a number, get first number. So you know already, first number is a variable. Get first number means we are getting an input from the user, and we assign this input to the first number. Okay. So here you can see the symbol. This symbol means we are getting input or we are giving an output. So here we are getting an input. So get first number, and again we are getting the second. We are getting another number, which is a second number. And here we have the processing symbol. So now we are doing some processing here. So what is the processing here is we are assigning the summation of first number and second number to a variable name total. And then again we have this symbol, output symbol or input symbol. Here we have this output symbol. We are going to display the sum of your two number is total. So here you can see the sum of your two number is inside the quotation. That means we are going to display this as it is. That means in the screen you are going to display the sum of your two number is. And you can see total is outside this quotation. That means we don't need to display the word total itself. We need to display the value of total in the screen. That's why the total is outside this quotation. I think you understand that. And here you can see, and finally, after we did these operations, we have to end this program or end this flowchart. So here you can, using this end symbol, we are ending the flowchart. And then we have this decision structure. So this is here you can see, instead of a top-down approach or instead of going top to down or in the normal path, now we can have two alternative paths. This is the decision structure. So in decision structure, we can have two paths according to the condition. So at first we are checking a condition in the decision structure. So if the condition is true, we have to take one path and do some actions. And if the condition is false, we have to take another path and do some actions. For example, see here, if the value of x is less than y, then again, if it is true, then we have to take the yes path, and it goes along this yes path, and it calculates the value of x as a as x times 2 and go with the normal flow of the program. But if the value of x is greater than y, then the condition does not satisfy. That means it returns true. Then it goes in the no path and it do another action. For example, here it calculates the value of a as x plus y. Okay. So this is the decision structure. And sometimes you have to do only one task. For example, if the value of x is, if the condition is satisfied, you have to do some work. Otherwise, you don't have to do any work, then you can go with the normal flow of the program. So here you have an example for this. So here we check whether the value of x is less than y. So if it is true, then you have to calculate the value of a as x times 2. Otherwise, you have to go this, otherwise you don't have to do anything. You have to go with the normal flow of this program. Then we have this repetition structure. So until now, at first we go with the normal flow of the program without taking any alternative paths. Then we have two alternative paths, and now we can repeat the structure using this repetition structure. For example, as you can see in this, here we have a decision structure. In this decision structure, we are checking whether the value of x is less than y. If it is true, then you have to do some action. That means you have add 1 to x, and again after adding value 1 to x, again they are going to the top of the decision structure, beginning of the decision structure, and again check this condition. So this have to be loop until the condition is, or this has to be repeat until the condition is true. So we'll see. So the action performed by a repetition structure must eventually cause the loop to terminate. So we have a repetition structure. So at any point, this repetition or this loop should be terminated. So otherwise, it is going to be an infinite loop. So here, see this example. In this example, they are checking whether the value of x is less than y, and if it is satisfied, they display x, and there is no changes happening to x. For example, at the first place, if this condition satisfied, so flow of the program is going to be in the yes path, and it display the value of x. Then again, it's go to the beginning of the decision structure. And here you can't see any changes in the value of x. So if at the first place, if the value of x is less than y, so since there is no changes in x, then this condition is going to be true forever. That means this loop is going to loop forever. I think you understand the thing. So here, there's no stop in this repetition. So if you do this to a program in your machine, then your machine is going to stop. That means your machine is going to do something forever. Then you have, most of time, you have to terminate the program or some things happen. Yes. Wait. Yes, Sunet. Then we must add some value to x. X plus 1, no, x plus 2, x plus 100, no. The thing we have to do is we have to increase the value of x. So if we increase the value of x at any point, the value of x be greater than or equal to y. Then we can exit from this repetition. Yes. Then we'll see how can modify this flowchart to stop this infinite loop. So here, to stop this, we have to increase the value of x. For examples, if we decrease the value of x, again, this is going to be an infinite loop. Because again, always, if at the first place, if the value of x is less than y, and when we decrease the value of x, then this condition is going to true for forever. So again, this is going to have an infinite loop. So for this, to stop this infinite loop, we have to add some value to x. So here in this example, we are adding 1 to x, or we are increasing the value of x by 1, or else we can do anything that increase the value of x. That means we can increase the value of x by 100, or we can multiply the value of x by 2, or anything. The thing we have to do is we have to increase the value of x in this condition. Okay, according to this decision structure, we have to increase the value of x. So if we change this thing as, or if we change this logic as this, so this repetition is going to stop at any time. For example, this will repeat 2 times or 100 times or 1000 times or any number of times, but this repetition structure is going to have an endpoint. Okay. Then we have this case structure. So we can have decision. So think you have to check multiple values against some variable. So for this, we can use decision structure, but it will be very complex. So instead of using decision structure, we can use case structure. So here you can see the case. We are checking the years of employed of an employee against these values. So if we take this case structure, it is very simple. So at first we are checking whether the value of years employed is equal to 1. Then if it is, we are giving this employee a bonus of 100. And if the value of employee is equals to 2, then we are giving this employee a bonus of 200. And if it is 3, we are giving this employee a bonus of 400. And if any of these doesn't match with the years of employed, then we have another option, which is other. Then the bonus of this employee is going to be 800. I think you understand this case structure. Then we have modules. Modules means we didn't discuss about these modules at the first place, so I'll explain it. Here you can see some symbol with rectangular with two horizontal with two vertical lines. So this means a module. That means for this function or this thing happening here in the module, we have another flowchart, or this is a predefined process. So this symbol represents that at this point we are having a module. For example, here you can see cal in this flowchart. We have to start the program and read the input. Then we have call calpay function. So here you have this calpay function. So calpay function is a predefined process. That means this calpay function have another flowchart. So if you need to do this function, you can go to the, if you need to do, need to know how we can do this, then you have to refer the flowchart named calpay. I think you understand this thing. Then you should, if you need to know how to calculate this calpay and how to do this implementation, then you have to go to the flowchart of calpay and do these things. And also we can combine these structures together. So here you can see, we can see a flowchart, and this flowchart segment, you can see two distinct structures. So at the first, so if we look at this flowchart clearly, here you can see in this flowchart, we are checking whether the value is within a limit. So in this limit have a maximum and this limit have a minimum. So here we are checking whether these values are within the limit, whether the values are within the limit. So whether this value is greater than the minimum and less than the maximum. So here at first we have decisional structure. They are checking whether the value of x is greater than the minimum. So if the value of x is not greater than the minimum, then we can say this value of x is not within the limit. Okay, this is the outside. This value of x is in the outside the limit. So if the value of x is greater than minimum, then we can have a little hope that this value of x can be within the limit. So we are going to go with this yes part. So in the yes part, we have a decision structure. In this decision structure, we are checking whether the value of x is less than max. So if the value of x is less than max, then we can say the x is within the limits. And if the value of x is not less than x, then we can see the value of x is outside the limit. I think you understand this logic here. And here we have an example for flowchart. So what's happening in this flowchart is, here you can see we start the program and we read name, balance and rate. That we are getting the input from the user name, and we are getting the input from the user the value for the balance and the rate. And inside the processing symbol, we are calculating the interest by multiplying balance with rate. And then we write name and interest. That means that now interest, and we display name with the interest, and we stop the program. And here we have another example of flowchart. Here you can see this flowchart is used to have a multiplication of any number from 1 to n. For example, if you need to get the multiplication of numbers from 1 to 5, then you have to input 5 as n. So we'll see here what's happening here is, first you have to input the number n, then it read the number n, and it assign the values to m and f. At first they are assigning value, so m is equal to 1 and f is equal to 1, and they calculate the value of f, and they check whether the value of m is equal to n. So if the value of m is equal to n, then you have to go outside from the loop and print the value of f. Otherwise, if the value of m is not equal to n, we have to go in the no path and add a value to m and go again to the loop structure. So here you can see this is going to loop until the value of m is equal to n. That means this loop is going to repeat until repeat n times. I think you got that. So we'll see, for example, we'll assign value, we'll get the value of n as 3. So in the first step, we are getting the value of f by multiplying f by m. So at the first step, the values of m is equal to m and f is equal to 1. So at the end of the first step, the value of f is equal to 1. And in the first step, we are checking whether the value of m is equal to n. Now the value of m is equal to 1 and n is equal to 3. So this condition does not satisfy. So we go with the no path, and here we add a value to m. And now at the end of the step 1, the value of m is 2. So we have to repeat it again, and this step 2, we are multiplying the value of f by m. Now the value of f is 1 and the value of m is 2. And after this multiplication, the calculation, we have the value of f as 2. And now the value of m is 2. And again, we are checking whether the value of n is equal to n. Again, it is not true because value of m is 2 and the value of n is 3. So again, we are going with the no path and adding one value to the value of m. And the end of the step 2, the value of m is equal to 3. So again, we are going to repeat this thing, and at the step 3, the value of f is 2 and the value of m is 3. And if we multiply these two numbers, the value of f becomes f becomes 6. And again, we are going with this decision structure. Now we are checking whether the value of m is equal n. So since after the second step, we are assigning the value, increasing the value of m by 1. Now we have the value of m is equal to 3. So now this condition satisfied. So we are going with the yes path and print the value of f and the n and then the program. So now the value of f is equal to 6. So we are going to have 6 as the output. So I think you understand this. And here, check this flowchart. In this flowchart, we are getting the average of 3 numbers. So again, we'll check this logic. For example, I'll explain this with you an example. So we'll get we'll input the number n as 3. So if you need to get the average of 4 numbers, then you should input n as 4. And if you need to get the average of 10 numbers, then you should input n as 10. So now I'm going to get the average of 3 numbers. So I'm input this n as 3. So at first step, I input the number n. And so after inputting the number, here you can see the program assign values sum and c to 0. And then we are getting the input number. First input number. So at first, we'll see the input number as 2. And in the step 1, we are calculating the sum by adding the sum to the number. So at the end of the step 1, we are having the sum as 2 and we are increasing the value of c by 1. So at the end of the step 1, the sum is 2 and the value of c is equal to 1. So again, in decision structure, we are checking whether the value of c equal to value of n. So here the value of n is 3 and the value of c is 1. So this condition does not satisfy. So we go again with the loop structure, and we are go again at the beginning of this loop to input a number. So in the second step, I am inputting, I get the input number as 6, and so in the second step, the sum is equal to 8 and the value of c is equal to 2. So again, we are checking whether the value of c is equal to n. Again, it is not, because the value of c is 2 and the value of n is 3. So we have to loop this, and again we have to get an input number. So as the third number, I'll input 4, and here you can see I have calculated the sum and C. So at the end of the step 3, the sum is 12 and the value of C is 3. So again, we are checking in this decision structure whether the value of C is equal to n. So here you can see now this condition satisfied because now the value of C is 3. So now we can exit from the loop structure. So the condition satisfied. So we can go with the yes flow, and here you can see now we can calculate the average by dividing the sum with the value of n. So the sum is 12 and the value of n is 3. So we are getting A as 12 divided by 3, which is equal to 4. So after this, we can print the value of A and end the program. So now you have to do some work. Draw a flowchart to find the product of two numbers using only addition operation. Okay, since you can't do it now, I'll explain this example. So to get a product of two numbers, what you have to do, you have to only use the addition operation. So think this as this. If you need to multiply 2 by 3, then what you have to do? The thing happening here is you are adding 2 3 times. I think you understand this concept. To multiply 2 by 3, that means you are adding the number 2 3 times. And if we are multiplying the value of 5 by 4, that means we are adding the number 5 4 times. I think you got this concept. So here in this flowchart, you can see this. Okay, thank you, Sunet. Here at first we have to get the input number A and B, and we are assigning the value of C to 0. And at this decision structure, we are checking whether the value of B is greater than 0. So if the value of B is greater than 0, then we are going inside this loop structure and we are getting the sum of A. So at first, in the first one, we are adding value of A to C. That means we are adding value of A, assigning the value of A to C. And then here we are deducting one from value of B. So, and we again go to the loop, and if the value of B is greater than 0, then again we can loop this one. So here you can see, if you think logically, this loop is going to loop B times. I think you can understand this. We are starting from where B have a value, and we are deducting one by one at each step until the value of B is less than 0. So until the value of B is equal to 0. So here you can see this loop is going to loop B times. That means we are going to add the value of A B times. That means, for example, if the values of A and B are 2 and 3, then we are going to add the value of A, or we are going to add 2 3 times. I think you understand it. And when the value of B is equal to 0, is not less than 0, then we are going in this no path and print C and end the program. So the next example is draw a flowchart to find the division of two integer numbers using only subtract operation and find the division and the remainder. So here you can see it. I'll explain this using an example. So first we'll get the value of A as 4 and the value of B as 2. And in the step 1, we are assigning step 1. So first we'll get the input and we assign the value of M to 0. So, and we are checking whether the value of A is greater than or equal to B. So if the value of only if the value of A is greater than or equal to B, then we are going to continue this loop. So here at the first step, you can see the value of A is greater than 2B because the value of A is 4 and the value of 2B is 2. And then we are going inside this loop. So at the end of this step 1, we are deducting A from B. That means we have the value of A as 2 at the end of the first step. And we are increasing the value of M by 1. So at the end of the first step, we are getting the value of A as 2 and the value of M as 1. So again, we are looping this one. Then again, we are checking whether the value of A is greater than or equal to B. So here you can see the value of A is equal to 2 and the value of B is equal to 2. So here this condition satisfied because the value of A is equal to 2. So here again we are going inside this loop and we are deducting value of B from A and we are increasing the value of M by 1. So at the end of the step 2, the value of A is equal to 0 and the value of M is equal to 2. So again, we are going to the decision structure and we are checking whether the value of A is greater than or equal to B. But now the value of A is 0 and the value of B is 2. So now this condition does not satisfy. So we are going outside of this loop and print the values of M and A. So the value of M is equal to 2 and the value of A is equal to 0. So here you can see the answer of this division is 2 and there is no remainder. And next we'll discuss about pseudocode. Pseudocode is an English-like representation of logic. That means instead of flowcharts, we can, in flowchart, we have a pictorial representation and we can, pseudocodes, we can have the text representation of a logic. So we'll see. We can convert a flowchart to a pseudocode. So here it is very simple. You can see in the flowchart, at first you have to start, then you have to do the things in words in a pseudocode instead using this symbol. So here start and get it input number. You have to write this and compute calculated answer as input times 2. Again, you have to write those things in words and print calculated answer and stop. So these are few words that is very useful for you when you write pseudocodes. So at first, this is the start keyword. So if you need to start your pseudocode, you can use this start keyword. And to input things, this is data retrieved. This is to retrieve data from the user. You can use this input. And to read and get. To read something or get something from a data file, then you can use this read and get keywords. And to print, display and show, you can use this, or to give an output to the screen, you can use this print, display and show keywords. And to do calculations, you can use this compute, calculate and determine keywords. And to set initial values, that means to assign values. I think at flowchart you saw that we assign some values to some variables at the beginning of the program. To assign these things, we can use this set and init keywords. And to increment a value, we can use this increment word. And to decrease the value, we can use this decrement keyword. So here we have a little example. Write a pseudocode for multiplying a number by 2. So it is very simple. First you have start, then get input number, then compute calculated answer as input number times 2. So get input number means we are getting the input number from the user and assigning this value to the input number variable. So now the value of input number is the value given by the user. Then compute calculated answer as input number times 2. So now next step, we are going to calculate the value of input, or we are going to multiply the input number by 2 and assign this value to calculated answer. Again, this calculated answer is a variable name. Okay. Then print calculated answer. Then we are going to print the calculated answer or the value of the calculated answer and stop the pseudocode or stop the program. Okay, this is all about flowcharts and pseudocodes. And next week, we'll discuss more about this, more structures, more about these flowcharts. Okay, there are many structures in flowcharts. So for today, this lecture is over. If you have any questions regarding this lecture, you can ask now. I can explain the things that are not very clear to you. So you can ask now. I can explain these things again. Okay, so I can see anyone don't have any question about this lecture. So we'll start this meeting, stop this meeting now. And you have to go to the LMS, and in this LMS, you have some activities to do. Do that activity and upload this to the LMS or messages online. And in this online, there is a chat here. So I'll be available at the Sages online chat. So you can ask any question from that chat. So thank you. Have a nice day.